In this episode, we want to look at how we can answer these 3 questions under the topic pressure. But before we look at them, let me take you through some formulas that we can use to do our calculations. Now, from the definition of pressure, what we said, pressure can be defined as the force acting on a body per unit area. So mathematically, we say pressure is equal to force divided by area. So in short, we can say P equal to F over A. In some cases, we can be asked to find a force. So force is equal to pressure times area. We can also be asked to find area. So area is equal to force divided by pressure, as we can see on the board. Now, don't also forget that our force is measured in Newton and our area is measured in meter square, and our pressure is measured in Newton per meter square or Pascal, as we can see here. Now, if pressure is equal to force over area, as we can see on the board, there are some instances where our force will not be given to us. So mathematically, force can be given as mass times acceleration due to gravity. Therefore, our pressure will be equal to mass times acceleration due to gravity, or divided by area. So we can also use this formula to do our calculation. We can even be asked to find the mass from this formula. Therefore, making mass the subject, mass will be equal to, that is pressure times area, or divided by gravity, as we can see here. Now, there are some instances where you may be asked to find pressure concerning some mathematical plane figures like square, circle, rectangle. So first of all, let us look at area of a square. All right, area of a square, which is given as what? L square. So mathematically, our pressure, which is force divided by area, will be given as force divided by L square, okay, as we can see on the board. If it's about circular object, so we can see area of a circle, which is pi r square. So our pressure, force over area, we can conclude by saying that the force divided by pi r square, where r is the radius, okay. And again, we can also be asked about pressure concerning rectangular object. So we need to know the area of a rectangle, which is length times what? Breadth. So pressure will now be given as force over area, but our area will be L times what? B, which we can also have this formula on the board. Now, we can also be asked to find pressure in liquid. So mathematically, we say pressure in liquid is equal to the density of the liquid, okay, times the depth, okay, which is the same as the height, times acceleration due to gravity. So we talk about gravity here, all right. So in short, we say density times the height times gravity. So this formula can be used to do calculation as well. Don't forget that gravity is constant, which is 9.89 meters per second square. All right, or approximately we can say 10 meters per second square. So if gravity is not given, we can use it as a constant here. Now, don't also forget that 1 meter is equal to 100 centimeters, and also 1 meter square is equal to 10,000 centimeters squared, and 1 kilogram is equal to 1,000 grams. So we can use this conversion period to change any of the units we are looking for into standard unit. All right, let's see how we can apply these formulas to solve these questions. Formulas that we study, let's see how we can use it to answer these questions on the board. Let us look at question number 1. we have been told that a regular concrete block weighing 5 kilograms. So we put our data down. The mass is given to us, which is 5 kg. All right, and it has dimensions. So the dimensions are given. That is 8 centimeters by 20 centimeters by 50 centimeters. And gravity is also given to us as 10 meters per second squared. And we have been asked to calculate the greatest pressure exerted by the block. Now, pressure mathematically is equal to force over area. All right, force over area. So we can say P equal to F over A. In this case, our force is not given to us, so we have to find our force so that we find our area, then we can find the pressure that we are looking for. Now, our force is also given as mass times acceleration due to gravity. Therefore, our mass is given as 5 and gravity is given as 10. So we are going to get, that is 50 Newton, as we can see. Now, our concern here is with the area. Since we are looking for the greatest pressure, we need to know that pressure is inversely proportional to area. So the higher the pressure, the smaller the area. So in this case, we also know that area is two-dimensional space occupied by matter. So we are not going to use the 3-dimension here. We are going to use only 2-dimension. So we need a smaller area so that we can achieve greatest pressure. And we are going to use, that is the 8 and the 20. That will give a smaller area. So our area will be 8 centimeters by 20 centimeters, which will give us 160 centimeters square. One thing we need to also know is that centimeter square is not a standard unit. We can't calculate it with a Newton. So we need to change it to meter square. So we divide both sides by 10,000 and that will give us 0.016 meter square. So now that we know our area now, we can calculate for the greatest pressure. Our force is 50. Our area is 0.016. So when we divide, we are going to have 3125 Pascal, or we can use Newton per meter square also, but we prefer Pascal because it's a standard unit. So this is how we can answer question number 1. Try question number 2 and put your answer in the comment section. Thank you.